In this video, we'll look at how to use the finance or time value of money function on your graphics calculator. Some of the more common graphics calculators are displayed here. Over the last 15 years, the look of the calculators has changed a lot, but the programs have remained relatively the same. This means you might be able to get away with an older calculator. Which calculator you use will depend on your own context. In this video, I'll provide screenshots of an older Casio, but I'll also be using the newer Casio. To enter the finance function on the calculator I have here, you press alpha and then C. Once we enter the finance function or the time value of money function in the older calculator, you'll notice that there's more functions here than what we'll need for this video. For the purpose of this video, we'll press F2 for compound interest. There we'll find a number of variables that we'll need to complete. N is the number of compounding periods, not the number of years. This is the number of years multiplied by the number of compounding periods per year. I, percentage. This is the yearly interest rate as a percentage. No need to convert to a decimal or to convert per compounding period. PV, like our formula. This is the principal or present value of our investments, which is our starting or original value. An important point to make is that the initial investment is considered an outgoing and therefore entered as a negative in the calculator. PMT is the payment each time period. For example, when a payment is required for a reducing balance loan, we won't be using that in this example here. FV, this is the future value or the final value of the investment or borrowing. P/Y, this is the number of payments per year. For example, when you pay off a loan, you may make a payment weekly, fortnightly, or monthly. This may differ from the number of compounding periods. C/Y is the number of compounding periods per year. You may encounter exercises where you need to compound weekly, fortnightly, monthly, quarterly, biannually, or yearly. P/Y and C/Y default to 12 per year. For the purpose of this video, the number of payments, P/Y, and the number of compounding periods, C/Y, should be kept the same based on the number of compounding periods. Let's look at an example. If $5,000 is invested at 8% per annum for 3 years, compounded monthly, what's the final value of the investment? How much interest is earned? So we enter the data into our calculator. So for N, we're going to equal 36, the number of compounding periods. Execute. The interest rate is 8%, so we enter 8. Present value, remember, is a negative, so we enter negative 5,000 because it's considered an outgoing. PMT, we're going to leave it as 0. So we just arrow down there. Future value, we'll leave as 0 because this is what we're trying to find. We'll leave P/Y and C/Y as 12. Now this time we're trying to find the future value. So we hit F5 on our calculator and we get the future value of this investment is $6,351 and approximately 19 cents. You'll notice on the screenshots I have here, this is also what we got with the older calculator. So the older calculator and the newer calculator operate in the same manner. The interest earned on this is the future value. Take away the present value. The interest earned is $1,351.19. Here we have another example. Robert invests in a term deposit paying 5.2% per annum compounded quarterly. How much needs to be invested to have $5,000 after 3 years? How much interest is earned? In this case, we're trying to work out how much needs to be invested. So let's go back to our compound interest menu and scroll up to N. N is 12, which is 3 years multiplied by 4 quarters. The interest rate is 5.2. We're going to put 0 as the present value because we're trying to calculate the present value. PMT stays as 0. The future value, we want 5,000. We're going to change P/Y and C/Y, which is our compounding periods, to 4 because it compounds quarterly and therefore 4 times per year. Now we're trying to find the present value, so this time we press PV, which is F3, and we get the present value of the investment would be $4,282 and approximately 10 cents. You'll notice that's exactly what I got in the older calculator as well, which I've provided screenshots for. Now we want to know how much interest is earned. We know our present value is $4,282.10. We take this away from our future value and we find that we earn $717.90. Let's look at how long it takes Dorian to invest $4,000 at 6.45% per annum, compounded half yearly, for it to amount to $10,000. Press exit to go back to our compound interest menu. This time we're trying to find N, so when we scroll up to N, I'm just going to enter 0 there. In I, I'm going to enter 6 0.45. Present value is 4,000. Remember, we have to enter it as a negative. PMT stays as 0. The future value, we want to see how long it's going to take us to get to $10,000, so we enter 10,000. And the compounding periods, it's half yearly, and that's 2 per year. So we enter 2 into PY and CY. And now to calculate the number of periods, we press F1 for N, and that's 28 periods. Remember, that's 28 6-month periods, so that's approximately 14.5 years, or 14 years and 6 months. Suppose Rose received $6,000 from a $5,000 investment account compounding monthly over 2.5 years. What annual interest rate did Rose receive? We'll press exit to go back to the compound interest menu, and we'll enter in our data again. This time we're going to enter 30 for N. We're trying to find the interest rate this time, so we'll enter 0 for the interest rate. PV is negative, or the present value is negative 5,000. PMT stays at 0. The future value is $6,000. And we're compounding monthly this time, so we enter 12 into P/Y and C/Y. This time we press F2 to find the interest rate, and we get the interest rate will be approximately 7.32% per annum. And that's it for this video. Thank you.